All right, guys, good morning. Today we're going to be looking at symmetry, and this might be a little out of order in terms of the way the math pages are in your sheet. I think your reflection page might come first, but I think it's important to talk about and understand and feel comfortable with the idea of symmetry before we move to reflection, because reflection is all about symmetry. So um, the whole idea with symmetry is that if you have a line of symmetry, you have a mirror image on one side of the line um, and on the other side. So um, things kind of look the same on either side. They're just kind of reflected. And the easiest way or the best way to see that is by kind of playing around with some shapes that you cut out from paper. And we'll do that with the second page of this assignment. And if you can fold a shape so that it exactly covers one half covers the other half perfectly, then that fold line is an example of a line of symmetry. If we were in school, we could use a tool called a mirror, and it kind of shows the same thing. But even that is a little trickier to figure out how to use well, and folding is something that we're all familiar with at this point in our school career. So let's just get right into these questions, and hopefully you'll have a little fun today with this. Here it says complete the picture. So it has a horizontal, which means sideways, line of symmetry, and draw it. Draw in the line of symmetry. So I'll show you with the first shape. I'm not going to do a lot of them for you because I don't want to take the learning away. But a horizontal line of symmetry is just going to be me kind of connecting these dots, doing the best I can with my traction pad. So there's my horizontal line of symmetry. And then if I wanted to finish the picture, which is also part of the question, I'll just change up my colors. And I want to make sure, okay, so I'm going to start at the top of the arrow, but really I want to know where to go. If I want to find this point, so 1, 2 for up, so 1, 2 for down. So that's probably where my arrow is going to go through this dot on the diagonal and back up to the top dot. And then up 1 square, and then left 1, 2, 3, 4, and up 1. So that's how you're going to show your completed picture with your line of symmetry. All right, moving on down, we have here it just says use a ruler and draw a horizontal line of symmetry through each figure. So sideways line of symmetry that splits your shape in half so that you could fold one side onto the other and they would match up perfectly. That's what you're looking for. Number 4, draw a vertical line of symmetry through each figure. So vertical means up and down, an up and down line of symmetry. Number 5, draw horizontal and or vertical lines of symmetry in the following figures. Some figures may have both lines of symmetry, horizontal and vertical, while some might not have any lines of symmetry. So you've got to play around with these shapes and see. I'd press lightly with my pencil in case you need to do some erasing. Here's more symmetry. Number 1, it says draw a line of symmetry through each shape parallel to line A. Parallel, so A is an up and down line in each of the examples. So you're just going to draw a straight up and down line, a vertical line. That's going to split these shapes in half so that they can fold perfectly on top of each other. Question 2 is interesting. Same shapes, same instructions. The only change is the word not. So this time you're going to draw an up and down line through the shape to split the shape in a way that is not symmetrical. And then we get down to some letter symmetry, which I really like. It's kind of fun. Many letters of the alphabet have lines of symmetry. Draw at least 5 letters of the alphabet to show their lines of symmetry. So here it shows A, B, and C. You've got to come up with 5 more. And B, can you find a letter with 2 or more lines of symmetry? Number 4, decode the word written in the mirror code by filling out the missing half of each letter. So this letter's been cut off here. So I just want to copy the shape on the line where it was cut off, and it should be a B. So that's a B. This is an A. Sorry, that I'm a little bit sloppy here with my traction pad and my mouse tool, but you get the idea of that little activity, which is great. Okay, so here's paper symmetry. It says cut out the shape shown here. So there's 4 quadrilaterals, rhombus, rectangle, parallelogram, and square. And you need to cut them out. Now, I know there's work photocopied to the back of this page. So what I did was I traced those shapes onto a different page. And I'm just going to cut out my parallelogram. And then it wants you to complete the chart below. But let's not get ahead of myself here. Let's read the instructions together. Okay, so I've cut out my parallelogram, and it says, predict how many lines of symmetry each shape will have, and write the answer in the chart. Well, if I go down to my parallelogram, which is the bottom one here, I think that if I fold it, maybe from corner to corner, it might have 1 line of symmetry. So my prediction could be 1. And then I'm going to fold my shape and try to figure it out. So the first thing I'm going to do is a vertical fold. And here I can see, I don't know if you can see it the camera. I know it's a small box of video, but it doesn't cover the 2 halves perfectly. So that horizontal doesn't work. What about like a diagonal from point to point? That's kind of what I thought would work, but I can already see that that is not going to work at all. Then the only other thing I could try is maybe a vertical line of symmetry. So I'm going to try to do it vertically. And again, I have parts of my shape that do not overlap. So there's no lines of symmetry in a parallelogram. Huh. Imagine that. So that would be what I would write over here in my actual lines of symmetry section. All right, and the last question here, different shapes to trace and cut out. One of them is a regular pentagon. These are all regular shapes, meaning that they have equal angles and equal side lengths. So first it wants you to know the number of edges, so number of sides. A triangle has 3 sides. A pentagon has 5 sides. Pentagon is the shape that I'm cutting out here. And I want to see if I can figure out how many lines of symmetry this shape has. So, okay, folding it this way, kind of horizontally. If I fold the shape horizontally, I get a vertical symmetry line. So there's 1. If I turn it this way, oh, there's 2. So I don't know if you can see what I'm doing here, but I'm just turning it kind of a 1/5 rotation each time. And every time I do that, I can make a horizontal or make a vertical line of symmetry. So I'm going to show you that with my draw tool. I made a line of symmetry kind of through the top down like that. I was able to make a line of symmetry like that. And I made one coming through like this. So the bottom base through the middle of the, from a top vertex through to the middle of the bottom base, I've been able to make lines of symmetry. And well, that's interesting. I have 5 lines of symmetry. So here I have 5 edges, and I have 5 lines of symmetry. Okay, see if you can figure out the rest of them. And then question B says, describe any relation you see between the number of lines of symmetry and the number of edges of a regular polygon. You might already have an idea based on what I did, but do a couple more and see if it fits your, let's use a science word, hypothesis. All right, that's all I got for you today in terms of support videos. Hope you have fun and enjoy your math work.